Physicists are enemies of the electrical science.
Yeah.
Physicists want to control everything.
Yeah.
They want their theories to rule the universe. It's a religion, is what it is. It's destructive religion.
But never did we back check our theory of living on a spinning ball, ever. You know, we don't do these problems. Why? Why don't we talk about the curvature? Why don't we talk about the velocity? You know, I went back to school and took astronomy in 2013, and we kind of talked about this, but not in depth like this.
Einstein was a big fan of equations.
There was a quote by Tesla. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. That's what happened with the globe theory. Everybody knew the world was flat until one day some guy came along and said, "Oh no, it's a ball. We're spinning through space. We're circling the sun." A lie is a lie, even if everybody believes it.
about the Earth being flat. Thousands of scientists have looked into it. You think they're all wrong? That's so insane.
You haven't looked into it.
I'm a structural engineer, and I've taken a lot of physics courses in my life, and I started to look into the curvature of the Earth and the rotation and the speeds of Earth, and it kind of blew my mind that I've never really thought about how fast the Earth rotates or how much it actually curves. You know, here I am researching flat Earth theory, and I'm actually studying the curvature of Earth and the speed at which it rotates. I mean, there's some serious irony there. About 7 months ago, or well, 8 months ago, beginning of the year on New Year's Day, I went and saw Interstellar, and I thought it was awesome. And it got me to go back and read this book for probably about the third time in my life, What is Relativity? It was written in 1959. Really good book, very good explanation of relative motion. From planes moving across the Earth with balls bouncing inside them all the way up to things traveling at the speed of light. It gives a really good explanation of Einstein's theories. And so, you know, here I am, my head in the clouds, thinking about relativity and space travel and all this craziness. And I was, you know, just bored one day, sitting on the couch, looking through YouTube videos, and a couple flat Earth conspiracy videos popped up in the, you know, that suggested videos to watch. And, you know, I'd seen those before, and I always had thought to myself, there's just no way, you know. But I'm a very open-minded person, and, you know, I was in the mood to watch something different, so I said, what the heck, I'll watch one of these, you know, thinking it would be good for a laugh. Well, about halfway into it, I wasn't really laughing. I was actually questioning a lot of things, and one of the biggest things that caught my attention was planes flying on a spinning Earth, trying to land on north and south runways. You know, the Earth rotates from west to east, and things don't seem to line up. Looking at Earth, watching a plane fly, and this is based on a direct flight I took in college from JAX to LAX. The two airports are about 2,000 miles away from each other, and you know, I flew there and then flew back, and I like doing the problem going back because it's just more interesting that way. It's true, because if the plane's already rotating with the Earth when it takes off, it's just the speed it gained in the air is added to the initial speed it already had. So that's not true, but there is a problem here, and that's what I want to get into. So these two airports are 2,000, here's my dimension line here, they're 2,000 miles apart roughly. We're just going to say they're 2,000 miles apart in order to keep this simple. Okay, and they're also, you know, they're not at the equator, they're north of the equator. A little over 2,000 miles, both of them. You know, Jacksonville's over here in Florida, and LAX is over here, to keep the problem easy. And so, as I was showing you on the ball, you know, as you move up away from the equator, the diameter of the Earth around the center axis decreases, so your velocity decreases. You can calculate this, and I played around with some numbers, and I got, you know, between 850 and 900 miles an hour for both airports. So I just said, let's just use 900, just to keep it easy. On the airport in LAX, we're going 900 miles an hour east. You know, the Earth is moving that fast, but we can't feel it because everything's stuck to it, right? So we're told. Since it was already moving, the velocity of the plane relative to Earth, which we'll call VPE, is now 600 plus 900 miles an hour, gives us 1,500 miles per hour. This thing's really moving. Okay, but it's relative velocity, so it only seems like 600 miles per hour to us on the plane, right? So we get up here to this point. Right before they make the turn, the plane slows down. Okay, this is where the problem comes in. Planes cannot stop flying before they make the turn. They can't go to zero. And going to zero would bring you back to 900 miles per hour that you started at. But you can't go to zero because a plane has to keep flying forward to have uplift on the wings and keep itself in the air. It slows down to 300 miles per hour. You know, and then it also, this is the speed it slows down to before it makes this 90-degree turn, or this right angle turn. So here, plane, right before it makes the turn, is traveling at BP prime equals 300 miles per hour. BP prime is just a new speed, okay? A new velocity in this direction. But it's also got its relative velocity to Earth, which would be VPE prime, is now 300 from 1500 is 1200 miles per hour. So now, as this plane goes through the turn, when it gets here, say the midpoint of the turn, it's got a vector of 300 miles per hour, which is its airspeed, this VP prime in this direction. But it also still has this velocity of VPE prime right up here, 1200 miles per hour. It doesn't lose that velocity. It can't, because the Earth is spinning under it, and it had that initial speed when it took off. The only way you can get rid of that is if you make the Earth stop spinning. So, when you get down here and you're trying to line up with the runway, you're going 300 miles per hour towards it. Make it look a little better. And you still got VP prime here, but you also have VPE prime. Well, there's a real problem there, because the airport, the ground over here, is moving, you can see that, at 900 miles per hour. We said the velocity of the Earth is the same at both airports. But the plane is moving to the east still at 1200 miles per hour. The plane is moving faster than the runway. They can't line up. But Newton's first law says that an object in motion stays in motion unless acted upon by an outside force. So an object in motion relative to another object in motion stays in motion relative to that object unless acted upon by an outside force. It has to. The atmosphere doesn't answer the question. And the other problem with the atmosphere is air gets thinner as you get farther away from the Earth. So the gravitational pull on the air as you get higher and higher is less. So by conservation of angular momentum, air at higher altitudes would have to be spinning slower. Everything breaks down to a simple algebraic expression. We go through all this proof to back check what these guys have done. But never did we back check our theory of living on a spinning ball, ever. We don't do these problems. Why? Why don't we talk about the curvature? Why don't we talk about the velocity? I went back to school and took astronomy in 2013, and we kind of talked about this, but not in depth like this. And then the other thing I started to think about is, I live in Central Florida. I heard a sonic boom one time from supposedly the space shuttle landing. Rattled my windows and doors, and it woke me up and scared the crap out of me. It was pretty awesome, actually, at the time. The landing strip for the runway at Cape Canaveral is north-south. The north end actually points a little bit to the west, this way. Actually, west is actually this way. But it's mostly north-south. And I also have seen the space shuttles take off on the beach. I accidentally saw one. I just happened to walk out on the beach up in Jacksonville one time and saw one take off. And I saw it go out over the water, going to the east, which would actually be this way. Going out over the water to the east, and then it disappeared from my sight. I thought it went out into space. So it's rotating with relative to the rotation of Earth. Definitely. And when it gets up into space, it's still going to have those components. It's adjusting with we're told it adjusts its movement in space with air jets, spraying mass out into nothingness, which I'm also going to do another episode on, because that doesn't make sense either. But we'll get into that too. So now this shuttle is going to re-enter the Earth's atmosphere, traveling at thousands of miles per hour when it comes back in, and it's supposed to come back in gliding. It comes through the atmosphere, and you've seen all those videos where the fuselage heats up, and it's slowing down, of course, as it's coming into our atmosphere. But if this thing is coming in at thousands of miles an hour, and trying to come in from either the north or the south end of that runway, and it definitely has components of velocity to the east or west, and that runway is spinning somewhere between 850 and 900 miles per hour to the east. This is insane. The little jets that shoot to the side and the shuttle aren't going to do anything in our atmosphere. This is insane. It doesn't work.